Hi, kids. Okay, today you are going to learn about a little bit about refraction and something called index of refraction. Okay, so to start with, let's say you have some air, and beneath the air some water, and then over here you have some air, and beneath the air is diamond. Okay, so first thing I would like you to do is to tell me, is that light going to go, that would be like the light traveling straight. That would be the light bending this way. That would be light bending this way. As if I call this like A, B, and C, um, which one is it going to be and why? Okay, and then how is this picture over here going to be different and why? So you are going to pause the video and you are going to, talk about and figure out which one is correct and why, and then you're going to draw how this picture would be different and you're going to explain why. Okay, so pause the video. Come on, you didn't actually pause it. Pause the video, you rotten kid. Okay, did you actually pause it? Okay, I hope you did. But with this one, well, when the light goes from air to water, the light is going to slow down. Why? Because it's harder for the light to travel through water than it is air. Well, if it's going to slow down, it's going to bend down toward the normal line. So if you look, this would be if it went straight. So if it's going to bend down toward the normal line, it's going to go like this. Okay? So the correct picture would be that one. Okay? This is easy to remember. If the light slows down, it bends down towards the normal. If the light speeds up, it bends up, and away from the normal. So it slows down, bends down, speeds up, and away. Okay? Well, how would this picture look differently? Well, the light's going to bend down towards the normal line, except it's going to bend down towards the normal line more. Why? Because it's going to slow down more. So this picture should have an even smaller angle of refraction. Why smaller? Because remember, you measure from the normal line. Okay? So this bends more. Why does it bend more? Because diamond, okay, is harder for light to travel through. Well, another way of saying that is that diamond has a in fact, diamond has a bigger index of refraction, okay, which is what we're going to talk about. So index of refraction is, now first of all, okay, index of refraction is going to be abbreviated with the lowercase n. So like if we were saying, so far we would say the index of refraction of diamond we know is bigger than the index of refraction of water, and we know that that's bigger than the index of refraction of air. Okay, why? Because the index of refraction is a number that tells you how many times slower light travels in that medium or that substance, and then as compared to a vacuum. To how fast light travels in a vacuum. Okay, so that a number that tells you how many times lower light travels in that medium as compared to a vacuum. So let's take a look at this. Okay, the index of refraction of air, for our purposes, we're going to say it's 1. Okay, in reality, it's like 1.00019 or something like that. Okay, and obviously all air is not the same density, so the index of refraction of air is going to change a little bit. For example, hot air has a slightly lower index of refraction. Why? Because it's a little bit less dense, which is why light actually bends when it goes from cold air to hot air or hot air to cold air. Okay, that's an example of how a mirage works, but more on that later. But for our purposes, essentially, we're going to say that that is going to be 1. Okay. The index of refraction of water is 1.33. So that means light travels 1.33 times slower in water than it does in a vacuum. Well, how fast does light travel in a vacuum? Light travels, if you remember the speed of light, lowercase c for the speed of light, is 3 times 10 to the 8th meters per second. And yes, this is on your formula sheet. Okay. So that if you wanted to figure out how fast does light travel in water, well, you would take 3 times 10 to the 8th and divide by this. Okay. And that would get you the speed of light in water. Or another way of doing this, and this is on your formula sheet, N equals C over V. Okay. Where V is the speed in the medium. So if you look, well, V equals C divided by N. So if you wanted to figure out how fast does light travel in water, you take this number, divide by that. Okay. The N of diamond is 2.42. So light travels 2.42 times slower in diamond than it does a vacuum. Okay. So it is really important that you actually understand what index of refraction is. Don't just memorize it, okay? You need to understand it, okay? It's just a number that tells you how many times slower light travels in that medium. You'll notice, okay, the index of refraction, speed over speed, meters per second over meters per second. Meters per second goes away. You'll notice the index of refraction truly is just a number. It doesn't have units, okay? Because the units end up canceling out. Okay, it's a ratio. It's a number that tells you how many times slower it travels. So just remember, if I am going from n equals, let's say, 1.33 to n equals 2.42, if I was to draw this, oh, well then I'm going from water to diamond, and my light is traveling this way. Well, if it goes from water to diamond, what is it going to do? It's going to slow down. It's going to bend towards the normal line. Okay. Now, it won't, that doesn't really look like it's bending towards the normal line, does it? Let's make it bend towards the normal line a little bit more. Okay. It won't bend as much as if it goes from air to diamond. Why? Because it's a bigger change in speed. It's a smaller change in speed. Okay. Hopefully that makes sense. Okay. Bye, kids.